Do you know that scientists are planning to terraform Mars into an Earth-like habitat? Seems like a daunting task if it is ever done at all. Terraforming the entire Mars would have to be done over several millennia. When life started on Earth some 3.5 to 4 billion years ago, Mars had liquid water and rivers flowing through it. It had its magnetic field to shield it against solar radiations. Therefore, the atmosphere of Mars was also dense. It had all the organic molecules and the favorable conditions to support life on Mars. However, sadly, Mars couldn't stay the same for a longer period of time. Mars lost its magnetic field some 3 to 4 billion years ago. It led to the solar wind, which is a continuous flow of energetic particles from the sun to ruin the planet's atmosphere and surface water, which eventually turned Mars into its present state of chilly desert. So, how are we supposed to transform a dry desert-like land into a lush environment where people, plants, and other animals can survive? Here's what it could take. Warming up the red planet. Are you kidding me? It's no easy job to warm up a planet like Mars. Mars' atmosphere is very thin and cold, and it cannot support liquid water on its surface. Mars has an atmospheric pressure of 0.6% of what the Earth has. Owing to this condition, any liquid water would quickly freeze or evaporate from Mars' surface. There are different point of views on the possibility of warming up Mars to make it habitable for living beings. People like Elon Musk have suggested the possibility of exploding nuclear bombs over the polar caps of Mars to raise its temperature. It is hoped that the nuclear radiations wouldn't pose any threat as it would occur in space over the poles. Moreover, the heat produced from explosion would turn frozen carbon dioxide into its gaseous form, and it would act as greenhouse gas to warm the planet and melt the water ice. There are many scientific, ethical, and legal questions that are raised at nuking Mars. Scientists predict that this nuclear reaction may produce melted water ice to a depth of few tens of meters over the Mars surface. But this would not last for very long. The carbon dioxide added to Mars' atmosphere by vaporizing the polar caps would only double the pressure, a far cry from the comparable pressure to Earth required for conditions warm enough to sustain surface liquid water and atmospheric water vapor. Another option for thickening the atmosphere of Mars and in turn raising the temperature of the planet would be to set up solar-powered greenhouse gas-producing factories. Humans have had a lot of experience with this over the last century, as we have inadvertently released tons of greenhouse gases into our atmosphere, which some believe is raising the Earth's temperature. The same heating effect could be reproduced on Mars by setting up hundreds of these factories. Their sole purpose would be to pump out CFCs, methane, carbon dioxide, and other greenhouse gases into the atmosphere. These greenhouse gas factories would either have to be ferried to Mars or made out of materials already located on Mars, which would take years to process. In order to transport these machines to Mars, they would have to be lightweight and efficient. These greenhouse machines would mimic the natural process of plant photosynthesis, inhaling carbon dioxide and emitting oxygen. It would take many years, but the Mars atmosphere would slowly be oxygenated to the point that Mars colonists would need only a breathing assistance apparatus and not a pressure suit as worn by astronauts. Photosynthetic bacteria could also be used in place of or in addition to these greenhouse machines. Another possibility is smashing ammonia-heavy asteroids into the planet to raise the greenhouse gas level.
Hurling large icy asteroids containing ammonia at the red planet would produce tons of greenhouse gases and water. For this to be done, nuclear thermal rocket engines would have to be somehow attached to asteroids from the outer solar system. Energy released upon impact would be about 130 million megawatts of power. That's enough energy to power Earth for a decade. If it is possible to smash an asteroid of such enormous size into Mars, the energy of one impact would raise the temperature of the planet by 3 degrees Celsius. The sudden rise in temperature would melt about a trillion tons of water, which is enough water to form a lake with a depth of 1 meter that would cover an area larger than the state of Connecticut. Several of these missions over 50 years would create a temperate climate and enough water to cover 25% of the planet's surface. However, the bombardment by asteroids, each releasing energy equivalent to 70,000 1 megaton hydrogen bombs, would delay human settlement of the planet for centuries. So the takeaway is it could take several millennia for the idea of terraforming to be fully realized. It took the Earth billions of years to transform into a planet on which plants and animals could flourish. To transform the Mars landscape into one that resembles Earth is not a simple project. It will take many centuries of human ingenuity and labor to develop a habitable environment and bring life to the cold, dry world of Mars.